Barry Mill is a working watermill that is an educational tourist attraction. It is probably the largest and finest example of its type still in operation. It is situated in a secluded area beside the Barry Burn, which provides its power. A dam and lady divert water from the burn, half a mile upstream from the mill itself. For centuries, this mill was the beating heart of the local community. It supplied essential food, served as a gathering place for trade, and was a centre for gossip and news. The first mention of a mill at this location goes back to 1539. Originally, there were 2 mills on the Barry Burn, both owned by Balmerino Abbey. One was an oat mill referred to as the Over Mill, and the other was a corn mill known as the Nether Mill. The names referred to the mill's position relative to each other on the burn that supplied their power. Over meant the higher mill, and Nether meant the lower mill on the Barry Burn. In the late 1600s, the Nether Mill stopped milling, and the building, constructed in 1783, is now used for storage. The Over Mill, which became known as Barry Mill, was destroyed by fire in 1814, and the structure seen today dates from its rebuilding by the owner. The mill was expanded in the 1930s and produced oatmeal until the late 1970s. Then it switched to making animal feed until flood damage stopped its operations in 1984. The National Trust for Scotland took over the derelict mill, and over the next 4 years it was fully restored to its 1814 condition. The basic idea of what goes on in a mill is a simple one. Oats are processed from an inedible raw material into a product suitable for human or animal consumption. The oats arrive in bags from local farms after they have already been threshed and separated from the stalks. The oats are dried in the kiln at the end of the mill. From the kiln they are shoveled down a chute to the basement or meal floor, where they are collected in sacks. The sacks are lifted by the sack hoist right up to the top floor, or bin floor, of the mill. Here they are emptied into a hopper, which fed one of the 2 pairs of stones on the milling floor. This pair of millstones, made of sandstone, shell the individual grains, and the output drops down a chute into the basement, where a fan separates the shelled oats, or groats, which ones are wanted from the husks, and which are not. The groats are then sacked up and again hoisted to the top floor of the mill. Here they are placed in the hopper, feeding the main milling stones on the middle floor, made of French burrstone. The resulting flour then descends into the basement once more, to be bagged for delivery to customers.
This is what we call the gear cupboard, for obvious reasons. We've got the pit wheel, which is this one, and that is connected to the same shaft as the water wheel, so that is directly driven, and it is driving what's called the wallower at the back here, which is quite difficult to see because of the beam, but it's this one here. And all that does is turn your horizontal drive from the water wheel to a vertical drive on the main shaft, and the main shaft powers everything within the mill apart from the electric lights. Yeah. Above the wallower we have this, which is called the Great Spur Wheel. And our Great Spur Wheel is basically a cast iron ring with holes in it, and each hole has a wooden tooth. These teeth are wood because they're sacrificial. If something in your mill jams or the mill stops suddenly, your wooden teeth should shear off. Traditionally these were made of apple wood, which is believed to be one of the reasons so many mills have orchards. You get the harvest in the autumn and you've got a ready supply of wood as well. Your wooden teeth are driving what's called a stone nut, which is this bit here. And you would have 1 stone nut for every pair of milling stones you had. So we had 2 stone nuts here. But you've got wooden teeth driving a metal cog, so the inevitable happens and they get worn. It takes quite a long time, but they do get worn. And it's wood, so it dries out, it also chips and splits. But because you've got 108 individual teeth, You can just knock one out and replace it. Your teeth would have been made either by the apprentices or by itinerant millwrights who would go around looking for work. Wherever you went, the holes in the great spur wheel for the teeth were approximately the same size. So you could make blanks of the teeth which were oversized and then just shave them down to fit. And inevitably you would shave one down too far so it was a wee bit loose. So you just wrap some sacking around it and put it in. Because between every pair of teeth there's a wedge. And that just locks your teeth in place. So even if it's fractionally loose, packed in with sacking, it's not going anywhere. Every 4 to 6 weeks you need to lift your stones, clean them, and if necessary redress them. While you've got the stones lifted, you will take out this shaft and check the condition at the bottom of it. It's just, the end of the shaft just runs in an oil bath at the bottom on a bush, not dissimilar to that. Now these are made of bronze or similar material and are relatively expensive. Millers were thrifty people, so what your miller did is put a penny in the bottom, and your penny is the same as the teeth. It's sacrificial, so that penny is going to wear before anything else does. So when he's lifted it, he checks his penny. If it's worn, he just chucks in a new one and he's saved himself some money. And if you ignore it, that is what happens eventually. How anybody could let it get that bad without noticing, I'm not very sure, but somebody did. Right. This is the miller's control panel. He can control everything he needs to here. I've got a water control, and all that does is adjust a flap in the launder to control how much water I'm getting. I've got the crook string, which adjusts the shoe under the hopper, which controls the rate at which the grain falls into the eye of the stones. If I've not got enough grain going in when I'm really close, the stones start to get warm. If I'm putting too much grain in, because I've got a very fine gap, my stones will choke and I grind to a halt. The third one is the tentering rod, which controls the gap between the stones. Turning this is making minute adjustments to how fine your flour is. So I'm doing a balancing act to get the speed at everything running at the correct speed. Milling properly, you want your stones running about 75 to 100 RPM. We've got 10 to 1 gearing here, so every one revolution of the water wheel gives us 10 on the stones. I'm regulating my grain so I'm getting it through at the right speed, and I'm regulating this to get the fineness of flour I want. Your see-out chute goes through the sieve, which is just for demonstration purposes. Originally, it would have stopped above the chute, and there would have been grids like this stopped above the sieve, and there would have been grids like this in the sieve. Anything that went through the grids was fine enough and would be sacked off. Anything that got trapped in the grids would go off the end into the small fanner, into the returns elevator, up and just straight through the system again. First thing you'll notice is that the noise of the water changes. It will start really quickly and then slow down.
Barry Mills stands today as a magnificent testament to Scotland's industrial heritage, set within a landscape where the stream still flows gently, birds sing overhead, and colourful flowers brighten the path, an evocative reminder of a world shaped by water, stone, and human ingenuity.